Hello everyone, welcome back to my YouTube channel. I am Pallavi. I am studying in Sri Venkateshwara College of Engineering from ECE department, second year, third semester. Today's subject is electronic principle and circuits. Today I am going to explain about Ebers Mole model and the hybrid pi model with the AC effects of DC voltage source and the equivalent circuits for the base bias amplifier and the VDP amplifier. Let's start the topic. The Ebers-Moll model is nothing but a T model because the circuit diagram is look like a T shapes. That why it called as an a T model. We can see the circuit diagram on the slide. With the circuit diagram, we can explain the T model. It can be used to carry out the small signal analysis of all transistor circuit. Across the collector terminal, we have collector current which is dependent on the current source. Uh, Towards the emitter, we have resistor Re dash with the voltage VBE. In between, we have base terminal. This VBE produce IB, so the AC voltage source is loaded by the input impedance of the base. Therefore, the AC voltage source is an input impedance Z in base. At low frequency, this impedance is purely resistive and defined as a Z in base equals to VBE divided by IB is considered as a equation number 1. Apply Ohm's law for a emitter diode. VBE becomes VBE equals to IC into RE dash is considered as a equation number 2. Substitute equation number 2 and in 1 it Z in base becomes IC into RE dash divided by IB. We know that IC equals to IB. Then Z in base becomes IE divided by IB into RE dash. Therefore, Z in base equals to beta RE dash. We know that because IE divided by IB is nothing but beta, we know that that's why Z in base becomes beta RE dash. The input impedance of the base is equal to the AC current gain time the AC resistance. The hybrid pi model, we can see the hybrid pi model on the slide. This circuit is look like a pi shape, that's why it's called as a pi model. Consider three terminal collector, base and the emitter. In between the base and the emitter terminal we have R pi. So write the resistance in between the base and the emitter terminal. The pi model is cost used than the T model because the input impedance is not obvious at the T model. That's why most of the time we use pi model than the T model. AC effect of DC voltage source. We can see the circuit AC analysis circuit diagram on the slide. Generally, we are here in AC analysis, we short circuited the DC voltage sources or the capacitor. We are short circuited and connected to a ground, AC grounds, that is called as an AC analysis. AC analysis is done after the DC analysis to draw an equivalent circuit from a given amplifier. So short circuit all the capacitor and the DC voltage sources is short circuited and connected to a ground and replaced with a transistor with an AC equivalent circuit. In AC analysis, we can calculate the voltage gain, current gain, input impedance, and the output impedance. This is the use of AC analysis and the AC effect of DC voltage source. The base biased amplifier, the AC equivalent circuit for the base biased amplifier. We have base biased amplifier circuit here with the three resistors RB, RC and RL, three resistors and the two capacitors and one voltage source. We want to convert it is an AC equivalent circuit. First, we should do the AC analysis for the circuit. In AC analysis, we should do the capacitors as a short circuited and consider input and the output. Here, the base part is considered as a input. The input is V in RB, beta RE dash. It is a input, and RC and RL it is considered as an output. The collector part is considered as a output. Collector current RC and RL, it is a output. This is whole part is called as a AC equivalent circuit. Using a pi model, hybrid pi model. VDB amplifier, AC equivalent circuit for a VDB amplifier. We have a VDB amplifier. VDB means voltage divider bias. We have that amplifier circuit here with the five resistors R1, R2, and collector resistance, emitter resistance, and load resistance, and two capacitors and voltage sources. We have this VDB amplifier here. We want to convert into AC equivalent circuit. For that, we want to do the AC analysis for the VDB amplifier. In a AC analysis, we should do the uh, capacitors as a short circuited here, and consider input and the output. And here V in R1 R2 is this base part is considered as a input, and the RC and RL this part collector part is considered as an output. This is the AC equivalent circuit for the VDP amplifier. Here V in R1 R2 beta RA dash, it is a input, and um I collector current, collector resistance, and loaded resistance, this is the output. This is the AC equivalent circuit using a hybrid pi model. In this video, we learned about the above small model, the hybrid pi model, and the AC effect of a DC voltage source, the equivalent circuit for the base biased amplifier, the equivalent circuit for the VDP amplifier. These are the topics we are covered in this video, and I hope all the concepts are understood, and this video is helpful for you people. And thank you to all for watching my video. Thank you once again.